Hi, everybody. So I'm here to present a course innovation grant that was given to the entire physics department as we tried to figure out what to do this year with laboratory experiences in the framing of distance learning. So I was elected to be the one to come and tell you all about what we tried to do to make laboratory experiences effective and impactful for all students, particularly those with really challenging places to learn during this pandemic time. So the barrier that we saw as a department was that our laboratories, which are central to many parts of our curriculum, as it is to many departments on campus, practical experiences are so important, just were not going to be possible, right? The students leaning over lab benches together and working with equipment and fiddling with knobs was something that just wasn't going to be possible. Some of our courses, it wasn't possible because they literally weren't here on campus, and even the ones that were on campus didn't have we weren't able to be in the same place because of social distancing guidelines. So we really wanted to provide access to a meaningful laboratory experience, and to make sure that access was equal no matter where a student was learning, on campus, in their dorm, in a house that had lots of resources, or in a house that did not. So we have 4 experiences this year that we needed to maintain in order to keep the curriculum going. And so I'm gonna talk about 4 different classes, and I'll give you a little bit more detail about each of these 4 classes soon. But I just want to say that 2 of them are sort of introductory experiences. One of them, our general physics laboratory, is a laboratory that follows along with our general physics class, which is required to be in the general physics class, and is really one of the experiences that's required for the pre-med track, right? So there was no option of getting rid of the laboratory for these students because it's something that is required for many of them in order to achieve their professional goals. The second introductory level thing was our gateway experience for majors, that we, even though these students were on campus, or many of them were on campus, we still wanted to make sure that students weren't pushed out of science because of circumstances or because of a half-baked first-year experience, because we all know, right, that the students that had a wonderful physics experience or a wonderful high school experience aren't in such need of this first-year experience, but many students are. Then our intermediate laboratory, again, many of our sophomores were on campus, but this laboratory was usually dealing with very sensitive pieces of equipment, measuring magnetic and electric fields, but also it's an important preparation for the sophomores before they get to the junior and senior year, where they go into our advanced laboratory courses. And then, of course, there's our advanced laboratory course. And in the fall, none of our advanced laboratory students, well, most of our advanced laboratory students were not on campus, and so that had to be a fully remote experience for an advanced physics lab, which again was a core experience for physics students. So let me go through them one at a time and tell you what the innovations were that were funded by the HHMI Course Innovation Grant. For the general physics lab, remember, this mostly not physics majors, I think completely not physics majors. This goes along with general physics. It's a sort of pre-med experience, right? It's the lab that goes along with that general physics class. This was fully remote because most juniors and seniors were not on campus in the fall. And so we went with a ship it and film it attitude. And again, because of access, right, we wanted to make sure that every student had the ability to do the hands-on part of the laboratory, no matter where they were. So we boxed up a kit of laboratory supplies. Sometimes it was as simple as pulleys or springs or balls, right, that we could use, but that were consistent between every single student. Those that had no access to a printer, we went ahead and sent them a printer because that's an important part of, if we needed to send a target or something for them to try to hit with another part of their lab, being able to print print out something or print out a graph in order to analyze it was something that was central to that laboratory experience. And so HHMI allowed us, the grant allowed us to ship out all of our laboratory supplies to every student and have them ship it back, right? So it also made it possible to do that. Because the labs then would be they conducted via Zoom through breakout room, but because it's hard to have that sort of lecture experience, we did move all the lectures to YouTube, which allowed us to have them subtitled and accessible before the laboratory started. So that way, while the students were working in their breakout rooms, again, most of the students had their equipment in front of them, right? But as they were talking to each other, there wasn't that time of passive ingestion, right? Because that was all done before class. And then if there were some labs, which there were a couple of labs where we just couldn't send out the equipment, either because it was dangerous or too delicate, or we didn't have enough for everybody, what we would do is we would film, or what we did was we filmed those labs and then provided the data. So it was that was the part that was unavoidable but less than ideal. But at least the students were able to do all of the write-up and the analysis and complete some of the learning goals of the class when it comes to things like error propagation, for example. So in this class, the students still had that hands-on experience, right? They were still able to connect what they saw in the lecture to the actual world because we were able to send all of this stuff out and level the playing field a little bit by giving people the resources they need so that everybody had the supplies. Now, classical physics, this is our gateway course, our other introductory course, but this is the one that the physics majors take. That's sort of a different story. Traditionally, or usually, or ideally, students would take both classical physics and the first year seminar, right, which is a course that's sort of research-based and centers around one of the research topics of a faculty member in the department. That was not going to be possible, right? The first year seminar tends to bring the students into a faculty member's research lab and work with the equipment there. We had no way of reproducing that, and we didn't want to do a strictly film it first year experience. So what we did was we reduced the total credit. So now it was a single 0.5 credit experience and just called it classical physics. But that classical physics experience was designed to be high impact and focus on those areas that we knew we needed in order to get students to have a meaningful physics experience. And so HHMI funded our ability to add metacognitive pieces to class explicitly so that students had a chance to do concept mapping and some other metacognitive techniques. But also, it allowed us to learn and perform activities that related to specifically belonging and identity, such as going through and discussing some of the American Physical Society reports on the experiences of underrepresented groups in physics, and then lastly, it helped us to focus on collaborative learning, right? This is another one of these challenges that I've been talking about in this video, that getting students to work together while they're not together or 6 feet apart is something that has to be done very carefully. And so the class then was built on this structure of providing for these meaningful extra layers. And a lot of that time was used by having some supplemental sessions where laboratories could be done in smaller groups, as well as collaborative activities, and also some activities centered on belonging. Now, in our intermediate lab, this is mostly sophomores. Again, most of the students were on campus, but we couldn't huddle around an oscilloscope like we used to, which is actually a ton of fun if you ever have the opportunity to do that, right? So again, one of the things that the CIG helped us with was to provide the resources to get all of our pre-lectures on video, right? Again, anything that's ingestive now, we tried to move that outside of the class period so that we could spend the time in class engaging with people, right? And it also allowed for that if a student was in class and had a partner that was a distance learner, they had the ability to still work together, right? Because they both saw the same video before coming to class, and now they're sitting down. One of them is sitting down at the lab bench, another is sitting down at a table at home, but they're able to interact with each other they're from the moment that class started. But the other innovation that the CIG helped us with was to replace our big old fancy experiments with some really clever, hands-on, not conceptual experiments, but experiments that took a certain idea and allowed students to really play with it. And so actually what you're seeing here is a fidget spinner magnet motor that each student built. And there are a lot of degrees of freedom here that you can change so that students can, so that groups can work together to try to see how fast they can get this thing to spin, or can they get it to change their, there are all sorts of questions that they can ask in an open-ended way. And that just keeps that engagement going, right? Active learning, being present, and being creative with physics. And of course, we had to ship some of those things out as well, which the CIG also helped to pay for. Now, the biggest challenge, as you can imagine, was our advanced lab, right? So students are required to take electronics lab. They can take it as juniors or they can take it as seniors. In either way, they weren't on campus. And this is the time when we use every student usually has an oscilloscope in front of them and a big old box of electronics equipment, and they're doing, they're learning to build power supplies and USB chargers and analog electronic. There's a lot of hands-on work that's going into the lab. And what the CIG allowed us to do was to take to expand our stock so that we had we had a piece of equipment for every single student in class, right? And these were not cheap. I mean, perhaps, when I was talking earlier about sending them balls and springs, these aren't balls and springs. These are sending people oscilloscopes, power supplies, function generators, and then and trusting them with them. And by the way, we had no adverse experiences. Everything came back 100% useful. But sending them everything they need to know to be successful in this laboratory at home, and then requiring a lot of synchronous time with faculty and with peers so that we could get through these complicated experiments. And this was very intensive for faculty members because it really was it was an exercise in time, in dedication, and but having that equipment, right? Everybody had the same equipment in their hands, and coupled that with the physics laptop program, everybody had the same software, right? They had the same computer. We were able to reduce the access barrier so that everybody had that experience, even though they weren't on campus. So what did our outcomes look like? I'm going to do each class. So I'm going to focus here on a beginning to end survey, okay? And I'm just going to point out some of the themes that have appeared from the class as a whole. And of course, we would like to dig deeper, combine this with actually some other grants and try to get some demographic information from it. But here I'll present just what we did from the high level. So for general physics, remember, our goal is to focus on having that meaningful physics experience. And there were really wonderful places where we saw a lot of growth in students. Actually, one thing that I'll mention, I guess, at the end is that there are no negative numbers. That actually, across the board, students saw a positive change in all of the questions that we asked when comparing the beginning of the semester to the end. Here, though, asking classmates for help with understanding assignments. This is a remote class, but yet the conversation and the focus on collaboration helped get us a really statistically significant increase in that. As well as belonging, right? So these are pre-meds in a physics class, feeling like they really belong there, and I think that's to see that growth over the semester is something that is just it's a wonderful thing to see. We saw the same themes with the classical physics class. These are, again, focusing on that identity and collaboration. Hopefully these students choose to enroll in physics in the future. Huge growth in being comfortable asking classmates, being comfortable asking professors. There's also a big increase in feeling like belonging, although the statistical significance wasn't as high. But again, positive, no negative changes across the board for these students. Now, in the intermediate lab, again, we have many fewer students who were in this lab. But what was interesting was that the most statistically significant outcome was the relationship between students and the faculty member, right? Which is where we want students to be in that level, right? As they transition from taking that large survey course or that introductory course into developing an identity as a physics major and preparing for the future. Being comfortable asking faculty for help or coming to faculty is part of is really one of the big goals. And there are also big increases in things like asking classmates for help, ability to overcome challenges, overcome setbacks in academic goals. Again, these are all places where we saw growth in our students over the course of the semester. And then the one that is actually quite touching is all of the statistical significance we found from our outcomes in the electronics lab, and that across the board we saw statistical significance in so many areas that had to do with perseverance, with belonging, with collaboration, and with relationships, right? And to look back at the pandemic semester as one where relationships were valued, I think is an outcome that that the department is really proud of. So final thoughts about this from the department, right? We didn't see a decrease in any of our metrics, which is something that we didn't expect, but was something that was great to see across all of the class. We also continued to see gains in belonging and collaboration during the pandemic, even with students who have already assumed a physics identity. And that impact really seems to be present throughout the curriculum. And so the ability to stay engaged and provide laboratory experiences to students over the pandemic, at least it seems like we didn't do any harm. And there's a lot of evidence to say that these procedures really helped. So again, thank you to everybody. The HHMI made physics possible, right? Or made physics laboratories possible in the fall semester, and that funding really went a long way to providing equal access to opportunities. Thank you to the Institutional Research Office for doing the surveys and helping with and continuing to help with the data analysis, and to all of the students that participated in physics labs this semester. And thank you all for listening to our thoughts.